Okay, so in this question, we'll be describing microwave, right? So part A, how do you prove that microwave is a transverse wave? So transverse wave can be polarized. So only transverse wave can polarize. Longitudinal wave cannot be polarized. So how do you differentiate between the two waves will be look for polarization. Okay, for question B. So microwave with a frequency of 1.52 times 10 power 9 hertz is used in the following double slit experiment. So determine the order of interference patterns seen on the screen right at point P as shown below. So what will we see at point P? Do we see constructive interference or do we see destructive interference? Okay, the first thing is let's find lambda. So lambda, which is C over F. C is the speed of light divided by the frequency, which is given is 1.52 times 10 to the power of 9 hertz. So this will give us a lambda of 0.197 meters, or roughly about 19.7 cm. Okay, so to identify whether we see constructive or destructive at this point, we have to determine what's the path difference. You can see, right, source 1, when it comes out, it has to travel through 100 cm to reach this point on the screen. Whereas source 2, when it comes out, it has to travel through this distance towards this point on the screen. So since this is 90 degrees, we can use Pythagoras theorem to find the distance between S2 and point P. So using Pythagoras theorem, we can find that the distance here will be 128 cm. Okay, so for source 1 to point P, the lambda is 19.7 meters. So how many lambda does it take for the light source to travel to point P? If the distance is 100 centimeter, and 1 lambda is 19.7 centimeters. So how many lambda does it take to reach point P? So using your calculator, we can find that the number of lambda will be about 5 lambda, right? So it's going to take 5 lambda. When it comes out, it's going to take 5 lambda to reach point P. Similarly, when the light source comes out from source 2, how many lambda does it take for it to travel 128 centimeters to reach point P? So using your calculator, 128 centimeters divided by 1 lambda, which is 19.7. So it's going to take roughly about 6.5 lambda. Okay. So the path difference will be who has to travel longer? S2 as compared to S1. So S2 has to take 6.5 lambda to reach point P. S2 is only going to take 5 lambda to reach point P. So the path difference is equals to 6.5 lambda minus 5 lambda. This here will give us 1.5 lambda. So the fact that the path difference is 1.5 lambda, we know that what we'll see on the screen, right, will be destructive interference. But the question is, determine the order of interference pattern. Okay, let's look at this. The order of interference pattern for disruptive. Okay, so let's draw out the pattern. This is your central maximum. This is your first order disruptive. So first order disruptive is when the path difference is n plus half lambda. So when we substitute n equals 0, this will be half lambda. So this is the second order disruptive, where disruptive again is half lambda, where we substitute n to be 1. So what we get will be 1.5 lambda. So since this is 1.5 lambda, this is 1.5 lambda, that means the order, right, is equals to the second order. Of course, the first order is when m equals 0. The second order is when m equals to 1. Remember, m must always be an integer value, 0, 1, 2, 3, and so on. So the first value that we can substitute will be 0. Subsequent value will be 1, and 2, and 3, and so on. So for the second order destructive indifference is when the path difference is 1.5 lambda.